Here I'm going to be looking at an algebraic method for dealing with quadratic equations called completing the square. It's basically taking a quadratic equation like this and rearranging it in the form of this. Now I'm going to show two videos using this same question. One looking at completing the square, and another way to solve this problem would be algebraic identities. The reason it's called completing the square is because what we do is we take this here, this quadratic equation, and we rearrange it so that one part of it is something to be squared plus or minus some number. So we will always have a part that's a perfect square plus or minus another number. Now, because we have a 2x squared to begin with, the first thing I need to do to solve this is take 2 outside of the function. By the way, this is a Leaving Cert past paper question that came up in 2017. So I take 2 outside of this, that's 2 outside of x squared. That's going to be minus 7 over 2x minus 10 divided by 2 is 5. Okay, so this is the part of the function here that I'm now going to be completing the square on. And I'm going to just ignore that 2 on the outside. So the trick is to take the coefficient of x, which is minus 7 over 2. We need to half it, and then we need to square it. And what we do is we add and we subtract that number. So if I take minus 7 over 2 and half it, I get minus 7 over 4, and if I square that, I get 49 over 16. So I'm going to add and I'm going to subtract 49 over 16. The reason I do that is because whenever you take half the coefficient of the x and square it, and then add that on, you have created a perfect square, like that. And then we're left with some number, which we just deal with afterwards. So just rearranging that there, we have 2 outside of x squared minus 7 over 2x plus 49 over 16, which actually is this square. To find out what square you have, we just take our coefficient of x and half it. So we have 2 outside of x minus 7 over 4 to be squared, and then this part here we still can't forget about the 2, so that is going to become 2 outside of 49 over 16 plus 5, which ends up being minus 129 over 8. We can't forget about this latter part here, which still has the 2 that's outside it, so we're going to subtract 2 times 49 over 16 plus 5, which is subtracting 129 over 8. So this is this function that we had at the beginning, just in completed square format. Now the reason we complete the square is because it allows us to get some useful information. For example, the local maximum or minimum of a curve. So in this instance, we know that the curve looks like this. Because x squared is positive, it's going to look something like this. And completing the square allows us to find the very minimum of the graph. Because this thing here, inside of my brackets, if that is not 0, then it has to be a positive number because I'm squaring it. And if it's a positive number, then it's increasing from here. So y is increasing. So the lowest possible value of y that we have when we complete the square is what's highlighted in green here. And that occurs when the value of x is opposite the number that's inside the brackets with it. So here, x is going to be plus 7 over 4. So the minimum point of my graph is going to be 7 over 4 and minus 129 over 8. The next part of the question just asked me if the roots are real. Well, for real roots, b squared minus 4ac is greater than 0, so that's just the minus b formula. We plug that in and we get 129, which is greater than 0, therefore the roots are real. Just to recap, the trick that you need to do, you add and subtract half the coefficient of x, making sure that the coefficient of x squared is just 1. So if it's not 1, just take it outside of the brackets like I did here. When we do that, then completing the square just rearranges the function and it allows us to find the minimum value or else the maximum value, depending on the type of curve we had. For the minimum value, the y value will always be the number we have here, and the x value will always be opposite the number that's in the brackets with it.